Let's now look at the systems-induced causes of upsets. This is where there's something wrong with the aircraft or its systems, and it's led to a condition where an upset can occur. Now these are becoming increasingly rare and are mitigated by a rigorous certification process and a lot of oversight from regulators and aircraft manufacturers. Additionally, operators and manufacturers closely monitor for trends requiring modification of parts or modification of maintenance procedures. And the dissemination of information related to failures is normally pretty rapid. However, it is a fact of life that failures still occur, and whilst they do, most are survivable if correct actions are taken. So in this section, we'll have a look at flight instrumentation failures, auto flight systems failures, and flight control systems failures and anomalies. Starting first with flight instruments then. Aircraft manuals offer workarounds to analyse, diagnose and respond to instrument failures. And all aircraft are required to have several systems which offer redundancy after a failure, and an assurance of availability of the minimum information to control an aircraft even after failures have occurred. So therefore, we should be able to survive any instrument failure through analytical thought and careful diagnosis of the problem. However, several accidents indicate that correct diagnosis action is not always accomplished. So the emphasis really in the case of flight instrumentation failures has to be on how are we going to recognise a failure and how are we going to diagnose it. Moving on to auto flight systems. These feed data from other aircraft systems and monitor your altitude, heading, airspeed and flight path. The accuracy and reliability of these systems has been noted to lead to complacency amongst crews. And additionally, failures can be hard to recognise due to the level of integration with other systems. For instance, with an auto flight system taking its airspeed reference from a failed airspeed data source, it may be difficult to recognise exactly what's happening. So the first action of an upset recovery must be to reduce the level of automation in order for the pilot to get a better feel for the aircraft. Finally, moving on to flight control and anomalies. Examples can include engine failures at low altitude or high power settings, control restrictions, flap asymmetry, spoiler problems, trim runaway, or shift in cargo position. And failures here can vary wildly and cause a problem that isn't instantly obvious as to what is actually going on. Therefore, there is very little guidance that we can give in how to counter or avoid these situations. And really this is going to depend a lot on your own systems knowledge of your aircraft and its limitations, and your own ability to think laterally around a problem. So have a think about your own aircraft systems knowledge. And perhaps this is a good opportunity for you to think through the information that was given to you in your initial type rating and the notes that you still have probably in your home somewhere. The key to a successful recovery in a flight control related upset is lateral thinking, good communication, and importantly to maintain a calm cockpit. In this brief then, we've discussed flight instrumentation failures, auto flight system failures, and flight control anomalies. But the key message here is that largely the opportunity is there for you to control the situation in any of these conditions given careful diagnostic and analytical thought, which can only come about from maintaining a calm cockpit.